That would be great for the live event. Okay, so maybe we'll get the door. I'm sure others will be coming in here, but don't want to make the whole lab hear me. So today we're going to be departing from our coverage of Ethica data sources and hitting a topic which is of urgent interest to a few people in this class, and that concerns the use of of Spark streaming mechanisms, with Twitter streaming as a particular example. A number of people here are processing Twitter data in the class for class projects, and others are interfacing with Spark streaming. And like many other aspects of Spark streaming is a very powerful mechanism, but it's also one that has evolved significantly among different versions of Spark. And the needs for supporting it also have some texture, because we're going to be exploring this, as we have many other topics, within Docker and Dockerized Zeppelin. And they're getting the requisite libraries to work well takes some sleuthing. We have some coverage which we're going to be putting in place here for Twitter streaming through Spark as a kind of example of Spark streaming. It's not going to be our only example. We'll actually see additional cases how we can use Spark mechanisms that are a little bit less specific, but and do things like keep track of the count of words found, etc. But for now, we'll tend to use Twitter and sort of collection of whole tweets as one of our prime use cases. So what I'm going to do here, oops, okay, I thought I shared the screen. There we go. So what I'm going to do is to switch over to a small presentation I'm going to be doing on this topic whilst getting us ready for Zeppelin. So while I'm presenting this, I am going to start up Zeppelin, and in order to do that, I'm in fact going to kill an existing Docker image that I have running right now, a Docker container that I have running, and I am going to start up a new one, just so we're starting from scratch, all on the same page. Okay, so I'll do a Docker PS. I confirm there's a Zeppelin running, so I'll do Docker stop Zeppelin. This was something I was working on with Winchell late last night, and I have to give credit to Winchell Chen for a fair bit of the details of today's lecture, and specifically the adaptation from older Spark version to this one. Okay, so I've just stopped that container. If I did a Docker PS, I'd confirm that there's nothing running now. And I'm going to start up my Zeppelin as we normally do with the normal processes. And because I have Zeppelin open in some windows here, I'm going to close that out. And I thought I have it open. There it is. Yeah. And I'll go back to it, or we'll go in and open it up within the new sort of Docker support. Here we go. And with Docker having been started, Zeppelin is there. I'm going to let's go to this and have this up. Okay. So we're going to be going through a bit of a tutorial on just to get you oriented with respect to Spark streaming and with respect to getting going within the context of Twitter API in particular. So I'm just going to get that done, and now we'll switch over to the presentation. Got to do one more thing here. I've just got to send myself these slides so we don't have to work through them all visually. Here we go. Okay, and there we go. Great. Okay, and okay. Oh, yes, fine. Got it. Okay. So here's the lecture. Basically, I'm going to be covering the streaming mechanisms within Spark as a major component of the Spark API. Spark streaming is something that complements the other features of Spark we've already been talking about, things like connecting to databases, things like using data frames, data sets, resilient distributed data sets, RDDs, things like writing out to a CSV file and connecting to file sources, loading in custom libraries. All of those things can work with streaming as well. Streaming is however, a common sort of common support needed for certain types of applications. And I'd particularly highlight online applications, applications that have online analytic processing in the sense that they deal with new data as it comes in, processing it as the data arrives. Okay, maybe we're interested in looking for certain keywords that have appeared on Twitter. Maybe we are interested in Facebook updates and looking for certain patterns there. Maybe we're doing online processing from emergency room postings here in the health region. Every time a new emergency room waiting time is posted, we want to do something with it and save it away. Maybe we write it off to a database. Maybe we alert someone if it goes above a certain level or what have you. There's a lot of applications where we're interested not in retrospective analysis over a pre-existing database of information, but rather we're interested in sort of real-time processing of new data as it comes in. Some of you will be familiar with analytic mechanisms of great significance in our lab and growing significance externally, things like the particle filter or particle MCMC, which are exactly geared to deal with new pieces, integrating new pieces of data, often in a Bayesian way, into existing probabilistic understanding about some situation out there in the world. So when a new data point arrives, we want to take it into account in our understanding of what's going on out there in the world and maybe what will happen. So we do particle filtering with a dynamic model, a simulation model, in a way that allows us to then give updated estimates for what might play out in the next few weeks, months, years, as new data arrives. And in general, there's a lot of applications, certainly not all, but a lot, which value dealing with each new piece of data coming in rather than simply on a one-time basis running with respect to accumulated historic data. They can update some understanding of the current situation, process the new data along in real time. And to support those sort of applications, it's long been recognized in the software pattern space that there are certain patterns that are well suited and very convenient for people to use in programs. And one of the more popular patterns out there is a thing called publish subscribe. Okay, the publish subscribe pattern posits that there's many use cases of situations where there's a publisher, someone who's sort of getting information that becomes available over time, and there'll be many subscribers to it. And the different subscribers may have slightly different needs, slightly different interests in that information. what subtypes of it or what have you they're interested. But they'll let the publisher know, hey, when a new piece of data comes out, send me this, or send it to me. So publish subscribe is a very well used software pattern out there in software engineering. And it's very well used because it's extremely convenient. It's convenient to handle these things asynchronously rather than polling and saying anything new arrive, anything new arrive, anything new arrive. You just get notified asynchronously, sort of whenever it comes about, you get notified about it and you can handle it, right? In earlier days, this would be dealt with by a callback. These days, we might pass a closure that gets called when this thing happens. And as you may know, elsewhere in the software world, this sort of reactive type programming has caught on a great deal. So we have, things like the React.js library with JavaScript. We have reactive functional programming with things like Frabjus. We have in things like AnyLogic events that are triggered and that invoke certain handlers. And of course, in building GUIs, building graphical user interfaces, we have event handlers that handle button pushes and clicks and various things like that, right? Cases where you want to navigate through a link or what have you. So this whole model of kind of signing up as a subscriber for some channel, often a channel that may have more than one subscriber. So you can have many subscribers to an event that goes off, is a very popular one. And it kind of goes along with what I would characterize as kind of a quiet revolution in software, which has occurred in the past 10 years to what's sometimes known as inversion of control. It's associated with a pattern called dependency injection. And dependency injection is one particular way of getting inversion of control. And the sort of chestnut that defines inversion of control is what's called the Hollywood principle. Hollywood is a place in the US where a lot of people want to work. And when they hire talent, they might have 1,000 people auditioning for one role in a movie. And they don't want those 1,000 people calling them and saying, did I get the role? Did I get the role? Is there a decision made, etc. Instead, as the Hollywood principle says, don't call us, we'll call you, okay? Meaning we'll notify you of if you've been appointed, if the important thing you're interested in happens. And a lot of software now, a very large fraction of software is created according to the inversion of control principles, Hollywood principle, inversion of control patterns. AnyLogic is just one example. There's many, many others, from web application development to, programming languages with GUIs, etc. So this is a very convenient pattern, and it's one that is supported by streaming. There's some additional components, though, too. If you have a database, a large database, and you have many people interested in updates to that database, it's actually fairly expensive and needlessly expensive to have all those different parties. Let's suppose 10 different parties. Let's suppose, in a very popular situation, hundreds or more, all hitting that database with occasional queries, again, saying, anything new happen? Is there anything new for me? That's a very disadvantageous situation, right? We try to avoid that in human-human interactions, and we try to avoid it with databases. And the thing to recognize here is that in databases, often there's a lot of different folks interested, a lot of different types of algorithms, a lot of different needs for being notified when new information arrives. So rather than having many, many independent queries, which query the database, time horizon and say, is there anything new since I last got it? We instead have a publish subscribe model where one central process monitors the incoming data. And when things arrive, it sends off update notices to various publishers or to various subscribers. Now, each of these subscribers may choose to get all updates, or they may choose to get a subset of updates, right? Or they may choose to get updates in more quickly batched fashion or last batch fashion. But there's an economy of scale here. It makes sense to sort of centralize this, because for each one, for example, the publisher needs to keep track, okay, I've already sent out things up to this time. Now I want to send things going forward from that, right? And the publisher can maintain that sort of information without each subscriber having to independently maintain that sort of bookkeeping information. In some cases, as Luce has sort of identified for me, there's also the process to actually offload the task of heavy-duty publishing sort of process work from the database task to a task which operates on the logs that are routinely produced as part of the log structured file systems used to support modern databases. So modern databases need to ensure the ACID properties. They need to ensure transactionality, where their operations are atomic, consistent, independent, and durable. This has very strong implications. Amongst other things, what it means is if an operation crashes in the middle of its operation, there needs to be a complete rollback of anything that happened since its beginning. So it's as if it didn't occur at all. With transactionality, we want it to be as if it totally has occurred or it hasn't occurred at all. And part of doing that and doing it well is actually maintaining via a log information about what's happened and having that log available even upon reboot of the machine to do the necessary work to put it in a consistent state. So transactionality is extremely important. It's what allows us to be sure that if we order a book via Amazon, say, these days anything else via Amazon, you know, either we get it and our credit card is charged, or neither happens. You don't want to be in a situation where, you know, you get your credit card gets charged and you don't get the item, and you don't want to be in a situation where, you know, they don't want to be in a situation where they send you the item and your credit card doesn't get charged. You want both to go on or neither one, right? You want it to be totally complete or as if it didn't occur at all. And so it is with a lot of operations. And part of the result of that, part of the implications of that, part of how that's ensured is by having rigorously maintained database logs. It's the presence of these logs that allows us in part to guarantee that transactionality. In part because it has to be able to roll things back that didn't occur fully. They were a lot of the way done and then it crashed or what have you. So ladies and gentlemen, in short, as Luce pointed out, because there are these logs that are created anyway, you can have in some cases other processes monitoring the logs than the database process. Noting when a new item arrives, for example, and being responsible for farming it out to a set of subscribers, rather than the database itself having to do a query, you know, query across the database, anything new, you know, you can be following these log files, a separate process than the database, which can offload things from the database server and help lower the risk. The database server is a bottleneck. Okay, so streaming is, you could view it as kind of one adaptation of a publish-subscribe model. Publish-subscribe model for the purposes of maintaining sort of real-time awareness of incoming information. Very attractive. Okay, so ladies and gentlemen, Spark streaming has a lot of different features to it. And we're going to be exploring them over the next few lectures, okay? It requires a different way of thinking about the Spark applications than what we've been pursuing thus far in our analysis code, et cetera. And it takes key advantage of some of the features that we've talked about associated with pipelines and associated with functional programming. Okay. In order to demonstrate streaming on Spark, we're going to be making use of a particular application-specific streaming interface, because Spark Streaming supports a wide variety of different types of information coming in as streams. An example is its ability to process logs with Flume, for example, log files from web servers with Flume. It can support many types of streams, but the stream we're going to explore today and in some subsequent lectures here is going to be the Twitter stream. Okay, so it supports the Twitter stream, and the Twitter stream is one whose support has been changing a little bit in Spark in the past year, and is changing more in the next year. Okay, and I'm going to show you over the next few times about how it's changed, so that you can get a bit of a glimpse of how it's used. It was used in Spark 2.0. How it's used in Spark 2.1 is what we're going to be exploring. And then I'll show you how it'll be supported in Spark 2.2, which is closer to 2.1. It's just a matter of shifting it to something called Apache Bahir. Okay, so what we're going to go through today is going to be a combination of principles of Spark streaming and principles of the Twitter API and Twitter-specific things. And I'm going to try to highlight which is one and which is the other. But just be aware, Twitter is going to be the major application example of streaming we're going to use. Okay? Now, because of that, we're going to need to get you folks set up to follow along this example. Okay? And specifically, if you want to follow tweets as they come in, you're going to need to get an account and, in fact, some credentials on Twitter. Okay? On Twitter. Now, that doesn't mean you need to send something out on your Twitter account. You know, you don't have to be tweeting this class, although I guess you're welcome to do so if you'd like to do so.
I already created a Twitter account.
Okay, that's good. Well, you'll be able to use your Twitter account. Sorry? Yeah.
For this app?
Yeah, if you have a Twitter account, you'll be able to use it for this app associated with the app, okay? If you don't have a Twitter account, we're going to create one. Now, I'll tell you, confession, I have a Twitter, but I've never sent a tweet on it. And there's 0 subscribers, I hope, because they're waiting in vain. Okay, maybe someone will eventually persuade me, like when he got me on YouTube. Maybe someone will persuade me to send a first tweet. But I may send it on WeChat first. Weibo. Okay, so ladies and gentlemen, we're going to go to apps.twitter.com. Okay, and there'll be an option on apps.twitter.com. I'm going to do this through an incognito window. Okay, here we go. So it doesn't remember me, just so you can get a sense of what's going on. So if we go to apps.twitter.com, it's going to ask us to sign in. Okay, and here we go. Okay. So if you have a Twitter account, please sign in with it, okay? If you don't have a Twitter account, you can actually do sign in here, and there'll be a little link to sign up now, okay? And then I'd like you to sign up. And if you want, you could use, I suppose, a fake name or whatever, you know, Nathaniel Osgood 3 or something. But I'd suggest that you you know, you take it, but you can't use it. It's not like you're forced to send tweets, you know, via this, right? And I'm agnostic about what this thing means. And you'll be signing up, okay? Okay, so here we go. During the okay. So once you've signed up, please let me know so I can signal the next step here, okay? Okay. Okay, so please let me know when you finish signing up. So who needs a bit more time? No? No? Okay, good. Okay, so what I'm going to do now is switch over to this other window. So I'm just trying to see if I can get a hold of my power bar because I'm worried about my power level here. Okay, so we're going to go quit this incognito window, and I'm going to reappear on Twitter according to my normal account. Okay, here we go. So, okay, no, you don't want to see this. Okay, apps.twitter.com. Here we go. So if you go to apps.twitter.com now, you should probably see a set of Twitter apps that's empty. Is that right? Okay. So you're welcome to engage in this behavior, but I'd ask you to create a new app as the main action you take on this screen, okay? And you're going to create a new app, and you're going to need to fill in some application details. And you could say, you know, CMPD898 sample app, you know, and give something to give something very very basic. Oh no. To my class. Okay, so sorry, I'm clarifying something with Christine in real time. She's streaming things to me. I think she is an outdated state. She thinks I'm still in the hospital where I was earlier. And so I asked her to bring my power bar, but she was afraid that it had to go to the hospital. Okay, so you want to fill in the application details, something about description. You could fill in for a website, Mumble. You could do the U of S website if you want. You could do any website you have to your grad student account or what have you. And you'll probably at least want to take a look at the Twitter developer agreement. Basically, it says what you're allowed to do here. And the services that you're allowed to use. Now, a key thing that I do want to highlight from here, okay, is that that you have rate limits, okay? In other words, and this is a binding limitation, we're not going to be able to get from Twitter more than a certain number of tweets per hour, okay? And I think it's actually per 15-minute interval, okay? So I think you can get somewhere between, last I checked, and last I bumped into it, it was between 5,000 and 10,000 tweets per 15-minute interval, I think. In any case, there's some particular bar where if you go over that, it's a threshold. If you go over that, they will declare you persona non grata for a certain amount of time. and that time is not forever. It's like a day or something like that, and you can't get new tweets during that time. Okay, so just be aware of that. There's statements about ownership in here and user protection, etc. But these things are worth knowing about, and it's probably actually our lab getting quite familiar with certain components in here. Okay, so this is the Twitter developer agreement. If you've read it enough to feel comfortable with it, you can then check that and create it. If you don't, you can just pull up to someone else who is going to go forward or watch me. Okay, you're not required to do that for the class, but so you would then create a Twitter application, and once you do that, it's going to get you to a screen like this. Okay, and you can go around different tabs up at the top here. With detail, settings, key, and access tokens. And one of the key things I need to communicate to you is that you're going to be setting up an application in Spark that's going to be using some information to identify itself. Information to identify the account associated with it, and to confirm, sort of authorize it to be dealing with your account, and information which is called a consumer key and consumer secret. Okay, so you'll notice this one here is a consumer API secret and consumer key, and I'm going to be invalidating this later because, as it notes, you should not make it human readable in your application so other people can see it. Okay. After that, you're going to want to go down and create your access token. Okay. Down at the bottom here, there's a create my access token, and that's going to allow you to specify an access token and secret. Okay. And the basic deal is that info is going to be placed in Spark with us. Now, just as the first day when we used Cassandra, we entered some information in sort of in a direct way, and later we put it behind the scenes in the interpreter. We're working towards a similar solution here. So you don't need to put this in full text right in your Zeppelin, okay? But in the meantime, we're going to be placing it in Zeppelin from here. So you're going to be copying these guys, the consumer API, consumer secret, and the access token, and whatever it's called, access key or access secret. So there's going to be 4 types of information that are long sequences of alphanumeric characters like this. You see that? Okay. I wish I could easily share it with you. It's not so easily done. Okay. So, ladies and gentlemen, I'm going to need to hide on my part this sort of information because I don't want this to go everywhere on the web, right? And probably I'm going to have to do a certain amount of editing. So what I'm going to do is I'm going to walk you through a set of steps that are going to use that information now that you have created it, okay? So this is the information: consumer key, consumer secret, access token secret. When you press that button, do you get these things? Do you see the access token? I'm so sorry.
What does it say when the guy who's running the class doesn't have his power cord?
It says he was tired when he went home at 10:30 or 10 o'clock last night. Yeah, yeah. Okay.
I brought both cords just to be on your safe side there. There you go.
Thank you, thank you, thank you.
I've sent you and Nate and Bo. I don't know where Rachel is, but I sent you a document to do. It's within your deliverables file.
Okay.
Good morning.
But I have a suggestion for Christine Hillis to help make her rightfully a web star. Let's give her a round of applause. Thank you. Okay. Thank you, Christine. Okay. Saved by the Christine once again. So, ladies and gentlemen, we're going to use this. Do you see this information? Was this generated? Okay, don't tell it to me. Keep it secret. Okay? And I'm going to try to keep mine secret from you. Okay? So how this is going to happen is I think I'm going to need to show you some things. Mine is down below. My secrets lie beneath here, okay? When I'm going to need to enter them, I'm gonna switch it back to something that will make it less pretty, but it'll be okay. I'm gonna need to show you something that's less beautiful than this code, far less beautiful, but will allow me to enter them. Okay. Specifically, I'm going to show my face, and then I'll enter them and switch back to this. Okay. So in the meantime, we need to go through some tasks. Okay. We're going to need to enter in, and I will enter it in here with you. We're going to enter in this sort of information. Okay. The key thing here is, of course, what is this doing? Where have we seen this before? Can anyone say? Yeah, this is a Maven string here. And it's a string which is basically specifying a location. We can download it on the Maven repository, a certain jar file. Okay. And it looks like this. Now, this merits some explanation. Org.Apache Bahir is a project that accompanies Spark, but has certain technologies that have been sort of carved off to go to Bahir instead of Spark Core. Okay. And one of those technologies is Twitter streaming. Okay. Now, Apache Bahir for Spark 2.2 is not part of the standard Spark distro. And it actually gets a little bit awkward to sort of go get it down, and you have to do some compilation, et cetera, on your own. But we're using Spark 2.1. Okay, if you go look here and you do spark.version here, what you'll find is this is Spark 2.1, okay, that we're using. And for that, I'm going to be showing you how to, oh, I shouldn't have done that. Oh, man. Why shouldn't I have done that? I should have executed this first. That's why. Okay. Oh, man. This needs to execute at the start of the interpreter. Okay. Now, I know what my response is to it, but we'll do it proper. We'll do it with the Winchillian way. So this is Spark 2.1, and what I'm going to show you works for Spark 2.1. You notice that for Spark 2.1, it corresponds to this guy here at the end of the string. This is indicating it's for Spark 2.1. 2.11 is indicating the Scala version. Okay, and then we've got some other information here. So Spark streaming is part of Apache Bahir now. Okay. Okay. So I screwed it up because I entered this before, and this started the Spark interpreter. Actually started the Spark up, and that's bad because this needs to run first. And if we tried to run this now, what would happen is we'd see a complaint. It says, "Hey, it must be used before it's initialized. Put this paragraph before." Yeah. Okay. So what we can do now, Winchell likes to do another way, but I think this way should suffice here. We could go up here in the settings, interpreter bindings. We could just say restart, and you say you want to restart it. Yeah. Okay. Notice I have Spark up here. If you did Spark Cassandra, it'll still work. Just start that one. Whatever's the default. Restart it. Okay. So I just restart it. Now I should note Windchill likes to go back to the sort of main Zeppelin screen, go to interpreters and do it there because he thinks it's more reliable. But I think this should suffice. So now having done that, we could do this, and it will be pretty clear if it restarted because it won't say that anymore. Okay. So I'm sorry for my blunder. Here we are. We're in a happy situation. So what this has done, what has this done? What hath we wrought? Well, this has downloaded this jar, okay, so that it's available. It's going to be available so we can load it. We actually haven't started the Spark interpreter until we execute additional things here, such as this guy, okay? And now it's starting up the Spark interpreter, and it's going to print out the Spark version. Great. And now I'm going to execute a whole swack of imports, okay? A whole swack of them. Let me go put them up here. And let us talk about where these fall, because this is a mixture, an agglomeration of different types of import needs, okay? This guy here is for Twitter utils. That's going to be supporting our Spark streaming. It's a Spark streaming source point for Twitter, okay, that it's going to be supported here. This last one is for something called Twitter for J, okay? And Twitter for J is something that provides an interface for Java in the JVM, for which Spark is, or Scala is totally compatible. Twitter for J is going to provide us with a set of classes that we can use to manipulate Twitter information. An example would be a place. So we want to ask for tweets from Saskatoon. Or an example would be a status, which it turns out can tell us, you know, if we have a tweet. And if we have a tweet, we could then start to ask who the user is. We can start to ask what's the place associated with it. We could start to ask what's the text. Okay, so it's a whole API for dealing with tweets. We will see this used outside the streaming context. We'll see it actually used in a querying context where it's more like, give me the tweets in the past few days. It's not incremental like, tell me when new tweets come. It's more like, hey, give me tweets from this time period for this place. We're going to go use Twitter for J there. But this up here, this here is for Spark streaming. It's a streaming interface. Additionally, we're gonna import org.apache Spark streaming generic things that have nothing to do particularly with Twitter, like seconds and streaming context. By the way, this is just wrapped, right? It should be on the same line, but it's on the big screen to accord with the Hollywood principle. And here we're going to import from org.apache.spark, and this is the Spark conf and Spark context, which will probably be frobbing a little bit. I actually don't think this is needed anymore in Spark 2.0. I'm not sure that we're going to need to use that, but I have it there. Okay. Do you get an error? Okay. Who's having an error? An error. Okay, what error is it? Okay, Twitter is not. Oh, okay. I know what that's due to. Right. So that is due to somehow this not being loaded properly. Okay. So let me see if I could recreate that. Ladies and gentlemen, don't do what I'm going to do. Okay. I'm going to do something which is just going to help debug this issue, but don't do it yourself. I'm just going to restart my interpreter so that I can do it. I'm going to see now if I can reproduce that without the jar file, in which case it gives us the clue that the jar is not loading properly, in which case I'll give you other advice, okay? Maybe whilst you're waiting for me, what you could do is you could do this. There's a bit of Winchillian magic that here. Could you run this command? I'll put it up on the big screen. It's like that. Spark.spark context.list jars for each println. And that's run, to be clear here, that's run in a Spark, the default interpreter, not the dep, not the first dep thing, okay? Oh, I have a theory about what it might be. Okay, I have a theory, but let me verify my hunch about what's causing it, okay? First, or about what's about some particular aspects of how it manifests. Okay, so I've just restarted here my whole Docker environment, and now I need to go. Now I need to go connect to it, and I forget the notebook name, but okay, so this is Zeppelin. Yeah, here we go. Okay, there we go. Boom. Okay, so here we go. And one thing that might be causing it is the following. Okay. Simple. Okay, so you notice right now that it's actually horrible. It's up. So I have Spark dep here. Make sure that this name matches up with the top one here. So if this is Spark, that should be spark.dep. If the top thing, by contrast, is Spark Cassandra, make sure it's spark-cassandra.dep, okay? Because otherwise it's going to be loading it into the other interpreter, right? Okay. Is it possible that was it? Or? Possible. I switched them and cool. Okay. So just to demonstrate this error, if I don't do this and I try to go on directly to that, I think I'll get precisely the error that you're talking about here. Okay. Yeah, it works. Yeah. Cool. Okay. Yeah, I think this is going to cause an error just like that. But what's really needed is you got to do that. So in order to sort of do this, I'll reset the interpreter, and now it's reset. So now I can hide these again, and I can do this, and this should, hey, oh man, right. Oh man. Okay, fine. Button is like hidden behind there. This is a tyranny of small screens. Oh, yep. Okay, that's fine. So it's loading it in from Maven, and now having loaded that jar here, I can load this guy. Boom. And these should all load fine. Okay. Are other people's working okay? Yeah. Okay. Okay, now I'm going to need to show you something far less beautiful than Spark code. Far less beautiful, especially than Scala code, namely my face. Okay, so here we go. And you know what? It looks like screen sharing has been off. Is that possible? Or screen sharing? Tell me, is screen sharing on? Screen sharing been on?
I don't know. I'm watching the stream.
I see.
Is anyone watching it?
Okay, well, let's. Okay. Sorry? Yeah, it has been on. Okay, so maybe I should mumble. I guess maybe it just got turned off or something. So, okay. So what I'm going to do is I guess I'll mute this guy. How do I mute? Boom. Ah, okay. Okay, and now I'm going to go to my secrets. So, ladies and gentlemen, I'd like you to, okay, now how am I going to show you this? Well, how I'm going to show it to you is I'm going to execute mine, and then I will copy it and sanitize it so that you can basically see what I did, the gist of what I did, and change it for what you need to do. So your consumer key, and you'll just modify it per your needs, mutatis mutandis. Okay, here we go. Boom. Your consumer secret, your access token, and your access token secret. So basically, you're going to create a bunch of vals, okay, each of which is going to have the strings that I've asked you to find, those 4 strings: consumer key, consumer secret, access token secret. Start putting them into your code right now, and I'll show you what to do with them. Okay, here you go. Okay, so now, ladies and gentlemen, you'll be spared the view of my face, and we will return to the beauty of the code. Right? Okay. Okay, here we go. Okay. There we go. Okay. Enough with ugliness.
You need to unmute the,
Oh, thank you.
the projector.
Okay, yeah, yeah, thanks. There we are. Okay, so it's wrapping a bit, but this should get you where you need to go. Okay, sc.setLog level error. This, I actually don't know if this thing is directly needed. I had it in there as a legacy thing, but I haven't tried it without that. The basic gist is you're going to be having a bunch of vals. These are read-only values, right? And they're going to correspond to your appropriate tokens, in quotes, right? Okay. So you'll have your consumer key. You don't want to copy down your underbar consumer key. You want to put your consumer key there. You want to put your consumer secret here. You want to put your access token and your access token secret. Okay? Now, having defined those, then what we're going to do is we're going to tell the Twitter for J OAuth API, authentication protocol information, about these, okay? So each of these guys corresponds to one of these, right? So each of these, the 4 we've just created, you're going to map to the appropriate thing here. And I apologize for this, but if there's a pattern I can point out here, it's all of these guys start with that prefix, and they end with just the corresponding names here. So you should be able to quickly put this together. You just have to type this once, and then you just copy an access token from that name, access token secret, consumer key, consumer secret. Okay? And with those, you're doing system.setProperty, and you're setting this property so it can access that information. Okay? So the one-time thing, we'll be able to use this information this time, next time, and maybe the time after that. Okay. Now, this is Twitter specific, but with many web APIs, you have an authentication need. You have to enter authentication information. They need to be confident they're dealing with a trusted party. and be clear about with whom they're dealing. So we're going to put that information in. Okay, so who needs more time? Okay.
So should it return null?
Yeah.
No.
I
Run again. I think I had this problem.
null. Oh.
When you run again, you don't.
Oh yeah, that's right. There is a problem with this, which I encountered last night. Which was if I ran it, sometimes I get a weird response, and then I just ran it again, and it was fine. Yeah. So that was weird.
Yeah.
Yeah. Yeah. So. Yeah, Winchell's response was immediately, he was standing next to me. He said, just run it again. Oh, man. Okay. 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 Do people need more time? Okay. Ladies and gentlemen, next. This is getting, so that was the last few things have been, well, have involved Twitter-related things, loading some Twitter libraries in addition to Spark libraries, and then setting this Twitter-specific stuff, right? That's all above us now. That's all behind us now, so to speak. Now we're going to be dealing with some stuff that are quite generic, okay? And this is something that will be reproduced basically for Spark streaming applications. So we're going to need to create a Spark streaming context, okay? And this is going to depend on something called the Spark context, which provides all sorts of information about the Spark situation, Spark status, together with a specification of how often we want it to stream to us. Like every minute, every hour. 5 is 5 seconds. And you notice we indicate that by saying seconds of 5. Do you see that? So we actually indicate this is 5 seconds by putting a unit around it. Okay, so, I should really put this into my slides just to have it for future reference. I'll just insert a slide here. Boom, new slide, and we'll put this in there because this is key Twitter code for Spark. Okay. Let's go back to this guy here. Okay. Next. So that was Spark General. This next thing, we're going to create a stream, a Twitter stream, for this streaming context. Okay. This is going to be a stream of tweets. So it's going to be like a hose to deliver tweets to us. Okay. And the way in which it's going to deliver them is in a batched way. It's going to give us the tweets which have occurred within the 5-second interval. So every 5 seconds, it's going to give us tweets or a batch of tweets. Now, sometimes that batch will be empty, and sometimes that batch will be full. What we're going to be doing here is just hitching ourselves up to the biggest hose there is on Twitter, which is all tweets, all public tweets. That's what we're going to be doing right now. Later, I will show you how we do location-specific tweets in the streaming way. And for that, we actually need the later version of Apache Bahir supported in Spark 2.2. Okay, I'll show you how that's done. You can specify a rectangle of latitude, longitude, and tell it, give me tweets within there, and it will give them to us. We can, through this API we're using here, access tweets which have certain information in them. But for now, this is the simplest one. I just want to keep it to sort of very simple situation. So you're going to do this tweet stream, and you're going to create a stream, okay? Based on the stream in context, which itself is based on Spark context and comes off every 5 minutes. Are you ready? Now, as soon as you create this, it's not like the tweets burst forth from Zeppelin, right? You don't see any tweets. That's because we haven't started it yet. The starting is going to be coming up here, down here, where we say ssc.start. Okay, we haven't started its surge yet. Okay. So what we're going to do here is we'll do the following. We actually have two things here that are going on, okay? Number one, we're going to be getting a tweet text stream, and we're going to be putting it out to a CSV file. But first, we're going to be taking the whole tweet stream, and for each and we're going to be processing within that tweet stream for each resilient distributed data set, which is associated with a certain time, count the number of new tweets here and print out how many arrived. Is that okay? Are we okay with that? Okay. Here we go. Okay. So what's going to happen here is, okay, sorry, I should do this. So tweet stream, where did that tweet stream come from? It came from this guy here, this create stream based on the stream context. This is a tweet stream arriving every 5 minutes, and it's going to consist of RDDs, resilient distributed data sets, just like we've been using behind the scenes. You know, sometimes we're not using data frames, data sets. We go to an RDD. We go to an RDD to show the lineage, the computation. Here we go. So we're going to say tweet stream dot for each RDD. This is a method. This is a function. It's a closure that's going to count the number of tweets and just print it out. Is that okay? Now, actually, we don't even need to do this fancy stuff. We could have even just done this. Get rid of this, and we could have just done, whoop, hey, this guy, just like this. Boom. That's also possible. Okay. In fact, I'm gonna. Tweet stream. Tweets. Oh, I didn't execute this yet. Yeah, the orphan one.
Curly brace inside your string.
Oh, mumble. That was not meaningful. No. Okay. There we are. Okay. Now, what we're further doing.
Are we supposed to get output from that?
Not yet.
No.
We haven't started it yet. In fact. Okay. Now, I'm tempted to do this. This is going to take a bit of time. Do you folks want to see output sooner? I know. Okay. So Vofu doesn't want to see output. Okay. Okay. Not yet. Okay. So what we will do here is we're going to write. Let's do the following. So I have this text here, which is going to actually turn. This is a bit of a mouthful. Okay. Basically, what's happening is I'm filtering out those which don't have a place. Those which do have a place, I'm extracting information about the place, the text of this tweet, and I am further going to be printing the latitude and longitude. For simplicity, just to give you less to type, why don't we just do this, okay? So what we'll do is we'll still be mapping it into a string. So what's happening here is we have a tweet stream. Tweet stream is filtered to only have those which have a place associated with them. And then for each of those, we will turn it into a string, right? Like this. This S means substitute string. This means it's going to interpolate. It's going to fill things in for these guys here. By the way, this is horribly bent around, I know, because of this. You know, this is meant to be right next to this guy here. It's wrapping it in strange, unseemly places, right? But the point is, we are printing out the text of the tweet, and we're printing out the full name of the place. Do you see that? And so this is mapping a status into that string, an interpolated string. So these guys get substituted out. Do you see that? Now, what is the status? Well, status is something that, again, gives us information about the tweet. It's defined in Twitter for J, okay? So if we do Twitter for J, and you go look at their Java docs, for example, and you were to do status.html, I suspect will be mapped here to this. You know, this is twitterforj.org. Yeah, you can then get information about the tweet, like, you know, when was it created, how many times it's been favorited by users, what's its geolocation, if it's available, the ID of the associated with it, whether it was retweeted, the number of times it's been retweeted, the text of it, the source of it. By the way, Yuan, notice it has like favorites and retweets. That could also factor into a machine learning algorithm operating on these, right? It's saying it. Did I retweet it? Is it a retweet? You know, has it been favorited at all? Etc. Okay, so this is Twitter for J, and that's the API we're using as part of this. Okay. Okay. So back to the salt mines. We were putting in this text. Who needs more time for this? Does anyone need more time? Okay, need more time. Do you prefer looking at it like that, or do you prefer looking at it like this?
You do a new line on the filter, and then on the map, it's much more easy to parse.
Okay, yeah, thanks, of course. So maybe actually what I'll do is do something like this, and then on the map, boom, something like that, and yeah, well, this is imperfect, but I'll push that down like that. Okay. So this is an interpolated string. This status provides information about the tweet, all these different things we just saw, right? Including the text, including the place. And we're just using some of that status information to turn this into a string. Do you understand that? Okay. Okay, so this is filtering according to this closure. This is mapping according to this closure. And what we get out is not a D stream of status anymore. It's a D stream of string, because it's mapped the status to a string. Do you see that? And this was a D stream. So this is a D stream of text, okay? String. Do you need a bit more time? Okay. Okay. So Let's then do this. I will share your thing. See, this is a D stream of string. Yeah. Okay. Now, what I'd suggest doing now, we only have basically 3 or 4 lines left here. If you want, you could do this first one. This will actually put it into text files that we can then look at. So I would suggest doing it, okay? And this is going to be a bit mysterious until I talk about partitions in Spark, which I will be talking about. And this has to do with the distributed nature of Spark. Suffice it to say that this code in Spark could be running on multiple processors on one machine, but it might be running on a whole farm of machines out there. Remember, Spark is designed for big data. And in general, tweet streams have RDDs, resilient distributed data sets. And as the word distributed as part of that implies, they can be distributed over a large machine and a large set of machines. And if we don't do a repartition, each of these machines may be saving the output on its own files, its own local file system. Every machine in the lab there would be putting them on its own file system. Repartitioning to one can allow all these different tweets to be gathered, or all these different outputs to be gathered together and output into a file, one file, for that time quantum, for that 5-second interval. Okay? But it's going from 100 different files over those different machines, each on its own file system, to one. Okay? So there's going to be one file output for every 5-second interval. 5-second interval coming from this. Okay? So, and then we'll save as text files, output. I think this is the folder it goes to, output. The output folder. Although mumble, actually, I'm not certain about that. And then you're going to do tweet text stream. Mind you, this is not the tweet stream. The tweet stream was a stream of statuses, of stati. It's a stream of statuses. But this is a stream. The tweet text stream is a stream of text, of strings. And that's the one we're repartitioning and saving as text files. And that's the one we're printing. Okay. Now this is, you'll notice there's something kind of funky going on here. We're saying, hey, print this stream. And you might ask, like, when is that running? Well, whenever it gets a new thing in it, it's running. Okay. So this print, this save as text files, that's going to be recurrently performed as these tweets come in every 5 seconds. It's not that these are only performed once. We may run them here. Watch this. Right? I just ran them. But the fact is, this print is going to be occurring every time new tweets are available. Every time new tweets are available, it's going to try to save them out to these files. Okay? In a folder called, actually, interesting tweets. That's correct. Okay. So this is, you can think of this, again, it's kind of monadic. It's queuing up promises to be executed, of computation to be executed when these arrive. A little bit like what we did with streams in Scala, where we had sort of this pipeline of things to be done to each element, right? And it did them in an incremental way as each new element became available. Okay. Are people done with that? Okay, next. These are the key things now. ssc.start, begin paren, end paren if you want. ssc.await termination, begin paren, end paren. This is actually going to turn on the hose. This is going to turn the hose on. And you will see the consequences writ large. Okay?
Can we turn the hose off without crashing Zeppelin?
Yeah. I think you could do ssc.stop, but I I'll have to check that. It's a very good question. No, it's not dot stop. Dot termin.
If you await termination, it'll just keep.
Okay.
And then you're stuck.
Is that right?
Yeah.
Really?
I'm probably gonna get banned.
No, you won't get banned. You can keep
Isn't
the.
there like a limit of 5,000 tweets per 15?
This is guaranteed to be within the limit.
Okay.
They're actually going to only be giving you enough that it's legal, that it's within their limits.
It's just, yeah.
Okay, but you can do other things in Zeppelin.
My interpreter's stuck.
Oh, really?
Yeah.
Oh, that's okay. Boom. And now these guys there, and here we go. Okay. Okay. So yeah. So do you see this? You see the tweets coming in? Okay. So you notice they're also tagged. Where did this information come from? Where it says place.
Pennsylvania.
Well, yeah, but the point is we actually said this. This is labeled because we told it to label it by the place, right? This is the string that we produced by substituting in the get full name of the place, right? We could have done this one better by putting in like single quotes around this or something like that to mark it. But fundamentally, it's showing these tweets. Now, you'll notice that it's actually doing this within here. So it will probably require you to scroll here. But as you can see, there's quite a variety of different tweets here. There's something like, I think, 10,000 tweets a second these days globally. And this is just a small sampling of the tweets. This is not all tweets globally. This is not all tweets with places just that are being put out. It's actually, this is something like 2% of all tweets globally that you get through this Spark streaming. If you don't have any restrictions, you just say, show me tweets, and you ask for those through this interface we've just used. If you just say, give me any tweets, it'll give you about, last I heard, about 2% of all tweets. Okay. Now, as we'll see, we can do things that are much more sophisticated than that. We can request tweets by keyword. We can request tweets by geography. We can request tweets, which we may be able to even say geotagged ones. I'm not certain about that. But in any case, we can request subtypes of tweets, tweets that mention a certain hashtag or what have you. And those we can get far more than a sampling of like 1% of. We can get all of them, for example, in the area that are known to be in the area of Saskatoon or in the area of Saskatchewan or what have you. We could do that through a streaming API that went by the name, I think, of the filtering API, but it's a streaming API, okay? And basically you put in place a filter and it will look for things with that filter that match that predicate in the filter. Okay, so this shows a little bit how the streaming is working, but we haven't finished quite looking at the output because there's one type of output that we have not yet examined. Where is that output? Yeah, it's these text files. So if you want to see those text files, you'll need to do something different. And this will only take a minute. So I'd invite you to follow along, okay? What you'll want to do is you'll want to use the little feature of Docker that Winchell taught me about, as normal. That's Docker exec -IT. We're going to execute it on the Zeppelin process. And we're going to specifically execute bin bash, okay, which is the bash shell, which is a command line shell, okay? Performing this will actually connect to that Docker Docker container that's running. The Docker container, which contains these streaming tweets, which are growing ever more numerous and varied in their character, right? Okay, so here we go. We're gonna execute this -IT Zeppelin, and it's gonna be bin bash. Make sure this is in quotes. So if we do that, you'll notice that I'm now root, but I'm root where? Inside of the Docker container, okay? Now, having done that, we can do an ls, and I can see, oh, there's an output folder, okay? Normally, you wouldn't have to do this, but I'm just showing you interactively, and then there'll be a way you can just copy things out of there really easily with the Docker copy command. But if we go to output here, you'll see that there's a lot of things there. There's many things. And what do you think this thing is? Any guess? Why is it going up by 5,000 at a time?
5,000.
Yeah, 5,000 milliseconds or 5 seconds. So this is all timestamps. But each of these is, if you do an ls minus LT, you'll see they're all folders. So these are all folders. And each of those folders contains within it. So if I were to do like output 113, okay, 1136, 610, da da da, interesting dot interesting tweets. Yeah, what I'd see is there's some folders or there's some files in some of them. Sometimes the files are empty. Sometimes the files are not empty. Like this one actually has something in it. So let's go. I'm going to just do part there. That file, I can cat it, right? And I'll see, okay. Oh, it sounds like they use chuffed in England as well. I thought that was might be an Australian term. But, okay. So, ladies and gentlemen, there's all these files. They're under these different folders, one for each time quantum. Now, if we had a farm of machines, it would be similar because we consolidated these on a single partition, and it could go onto a single machine. But we still have to deal with the fact we have these things from different time periods, right? So one thing you could do would be to do a find dot minus type file. I'm going to find all files here. There we go. And I am going to look for things with a name part this. We're going to find all those. And then I'm going to do xargs tail. And that's going to take all of the output of this, and it's going to put it as arguments for the tail function. And that's going to show you for each file what's in that file. Sometimes it'll be empty, okay? Here we go. España. This one is empty. See that? Nothing. Yeah. This one has a fair bit, it looks like, in it, etc. Anyway, this is what we can do to sort of inspect interactively. Realistically, what we'd probably do is consolidate these. So, you know, you might, if you didn't want to know where each of them came from, you could do it to cat. This is a complete thing. And right now I have 429, right? 429 lines associated with this, and something like 40,000 characters and 5,100 words. Now I have 445 lines. You could see it's accumulating over time. What is this doing? This, again, is finding all the files, catting them all, and I'm just counting the word count. Now it's 450 lines, 450 different tweets, because each tweet is, most tweets are on a line here, okay? So it's something on the order of 450 tweets there that have been captured, 462 tweets. They're coming in. thick and fast. Okay? So this is Spark streaming as its most basic. This is Spark streaming, as Dorian discovered, at its most paralyzing. But it does demonstrate the basic. Okay, not all the English, I approve of these. Yeah. In any case, it's a diversity of tweets expressing different opinions. So that's all for today. Next time, we're going to be taking a look how we can filter these tweets by certain ways. And we will take a look how we can filter them for later versions of Spark according to geography, okay? We will then be looking also at an interface to Twitter, which will allow us to retrospectively get these, and which will have some extra flexibility with it. But the tweeting interface is of keen interest, the streaming interface rather, in catching these things going forward. Okay, that's all for today. Thank you for your patience with this, and be sure to keep your Twitter credentials handy, because we'll be using them again next time. Thanks much.